This beautiful periodic chart of the elements was published in 1950, but is still valid. Why today we have this chart with us? Because we today show you a very important mineral which is called zircon. The zircon is done by silicon, by oxygen, and by zirconium. This is the formula you can see. Okay, so but look, this mineral is important not just because it's made up by these elements, but because it contains some impurities. Such impurities are mainly lead and uranium. And you must know that in geology we use these elements, actually we use the isotopic composition of these elements to determine the age of the material that contain these elements. In particular, right lead and uranium dating is used for zirconium. So another very important issue about this mineral is that some years ago this mineral was found in Australia, and the age of that zircon was 4.5 billion years ago. So actually this mineral is one of the most antique mineral that we can find in the earth. In my hand right now you can see a beautiful crystal of zircon. You can see this is a 3-4 centimeter large crystal, but of course we don't have every time available this kind of crystals. We have much more smaller samples, but that's fine. Maybe you heard about zircon in a different field. Sometimes if the zircon is colorless, transparent, without any defect, it can be used instead of diamond for rings. So, but this is not our topic today. Turning back to the zircon, we said that in Australia it was found very old zircon, 4.5 billion years ago. And this year, just now, they published in Geology magazine and reported also by Nature that we found, my colleagues from Baton Rouge University found crystals of zircon from close to Pretoria in South Africa, and these samples were dated by uranium lead system, and the age of these zircons were around 4.1 billion years ago, so very, very old as well. And at the same time, even in India, this year it was found again some zircon in the Hadean period. So why this is very important? First of all, you should remember that 3.8 billion years ago the Earth was bombarded by a very, very strong and intense asteroid and meteorites impacts, and this clearly sign a very different story about the Earth before 3.8 and after 3.8 billion years ago. So zircons are older than 3.8 billion years ago in these localities, and therefore we can get important information about the Earth, very, very, very primordial Earth, let's say. Sometimes when we are very lucky, in these crystals we can find some hydrogen. And when we find hydrogen in this material, since we know also the age, we can determine the deuterium-hydrogen ratio, and this could be compared with the same ratio that we find in asteroids, in comets, and in other planets in our solar system. So the idea is to understand if the Earth was born with hydrogen already, or the hydrogen came to the Earth later than its formation. So zircon can be a really key mineral to understand the early evolution of our planet.